This video is for Mrs. Cucci's College Now Pre-Calculus class. We are in lesson 5.4, radians, arc length, and angular speeds. If you want to go ahead and get this file opened up on your calculator, we'll get started. Okay, so by the end of this lesson, you will be able to find points on the unit circle determined by real numbers, convert between radian measure and degree measure, find coterminal, complementary, and supplementary angles. Find the length of an arc of a circle. Find the measure of a central arc or a central angle of a circle. And convert between linear speed and angular speed. Okay. All right, so another useful unit of angle measure is called a radian. So just like when we're talking about temperature, we can talk about degrees versus Celsius. It's just a unit of measure. So we have degrees and radians. We're going to be talking in terms of radians today. So to introduce radian measure, we use a circle that's centered at the origin with a radius of a length 1. This circle is what we call the unit circle. Its equation is x squared plus y squared equals 1. And we did quite a bit of work with the unit circle last year, and we're going to do quite a bit more with it this year. Okay, so in class, we will be making a unit circle paper plate. I believe we should have already done this prior to this video, so we'll go on from there. All right, so how far will a point travel if it goes A, 1/4, B, 1/12, C, 3/8, and D, 5/6 of the way around the unit circle? Okay, so the first thing we kind of have to think about is knowing how far we actually have of a circle. Now we know the number of degrees in a circle is 360. If we're talking in terms of radians, we know that radians, where it would normally be 360, we would have 2 pi. Okay, so here's my unit circle. Not a very good circle at all. We know we're here 0. If we go all the way around that circle, this is 2 pi radians. Okay, this would be pi, this would be pi over 2, and this would be 3 pi over 2. So essentially 0, 90, 180, 270, 360, or in radians, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if we want to know a quarter of the total distance around the circle, all we need to do is take a quarter and multiply that by 2 pi. This gives us 2 pi over 4, or when that gets reduced, pi over 2. So a quarter of the entire circle, this should make sense. Here's 1/4, 2/4, 3/4. So 4/4 makes up the whole circle. 1/4 would bring us to pi over 2. All right. All right, so we're going to follow that same pattern. 1/12 times 2 pi is going to give us 2 pi over 12, which we know reduces to pi over 6. 3/8 divided by 2 pi is going to give us 6 pi over 8, or 3 pi over 4. And 5/6 is going to give us 10 pi over 6, or 5 pi over 3. Okay. Now, if we wanted to take a peek at what these look like on a rotation diagram, we could absolutely do that. And we just talked about 1/2 pi. So we know on the unit circle, the 1/2 pi is going to be right here. Okay. So this is A. For B, pi over 6 is 30 degrees. So it's going to be about here. 3/8 or 3/4 of a pi. Remember, this is pi. From here to here is pi. So 3/4 of a pi would be about here. Right? Halfway would be 1/4, 2/4, 3/4, 4/4. And then 5 pi over 3 is going to be more than 3 pi over 2. It's going to be about here. All right? So that's about where they fall on that unit circle. Okay. On the unit circle, mark the point determined by each of the following real numbers. All right, so we have 9 pi over 4 and negative 7 pi over 6. Okay, so we can think of 9 pi over 4 as 2 pi plus 1/4 of a pi, okay? If we were to break this up, we would have to have a common denominator, right? This would give us a denominator of 4. But we would also have to multiply this by 4, which would give us 8 pi over 4 plus 1/4 pi, which would give us 9 pi over 4. Okay, so that's the breakdown if you were wondering how I got that. So if it's 2 pi plus 1/4 of a pi, what that would look like on that unit circle, okay, I know that I'm going to go all the way around once, and then I want to wind up at 1/4 of a pi. Remember, this is pi here. This is pi over 2. Oops. This is 0, 3 pi over 2. Okay. So 1/4 of a pi, 1/4 we know is half of a half. So it's going to be 1 full rotation plus 1/4 of a pi. So right there is going to be 9 pi over 4. Okay, so around and then to about here. Okay. All right, 7 pi over 6. I know my circles are not pretty, I apologize. All right, so 7 pi over 6, or negative 7 pi over 6, we know that we're going to be moving in the clockwise direction instead of the counterclockwise. Okay, so we're going to be going, we could say, from A to B instead of from in this direction instead of in this direction. Okay. All right, so we know that pi is 180, or if I'm going from here, I can think of pi as 6 pi over 6. Okay, so what I would need is another 1/6 of a pi to get myself 7 pi. We can make those both negative, so that works out right. Okay, so what I'm going to do is going from here to here. Remember, I'm going clockwise. I'm going to go 1 pi, and then another 1/6 of a pi. So from here to here, we're going to go 1 pi, and then another 1/6 of a pi. So maybe it's about here. And it's going to go in this direction because it's a negative rotation. All right? So this would be negative pi, 7 pi over 6. Okay, so let's talk radian measures. Degree measure is a common unit of an angle measure in many everyday applications, but in many scientific fields and in mathematics, there's another commonly used unit of measure called the radian. So we kind of talked about this a little bit more, and we've done a lot of work with this over the past few years. We know that 360 degrees is equivalent to 2 pi radians. Okay, so we kind of build off of that knowledge to determine the rest of the radian measures that we'll be using. Okay, so if we want to do a conversion from degrees to radians, we have a really nice easy proportion that we've used in the past, and that proportion is degrees over radians equals 180 over pi. This can be used to go from either degrees to radians or vice versa, radians to degrees. Okay, either way is going to be this method will work. Okay, so we're going to convert each of the following to radians. We've got 127 or 120, which is a nice even number, and then negative 297.25. Now, it doesn't matter if the numbers are pretty or not. That proportion is still going to work for us. Okay? So let's start with our first one. We've got 120 degrees. So we're going to use that proportion. Degree over radian equals 180 over pi. So we know I have degrees. What I'm looking for is radians. And let's say that I call it theta equals 180 over pi. I'm going to simply cross multiply, giving me 120 pi equals 180 theta. I'm going to divide both sides by 180. And then reduce this fraction. We know those zeros go away, right? 12 over 18, which is going to reduce to 2 pi over 3. All right? So 2 pi over 3 radians. And if I wanted to figure out what that is as a decimal in radians, I could just pop it right into my calculator, and that's about 2.09 radians. These are equivalent, okay? All right, so let's look at the next one, negative 297.25 degrees. Same proportion. Still going to cross multiply. And divide. Oops. And when we put that into our calculator, we put it in just the way we see it. We get negative 5.19 radians. And you'll see radians written in terms of pi, like this one over here. You'll also see it written as a decimal, so you do have to be comfortable with both notations. Okay, so convert each of the following from radians to degrees. Okay, 3 pi over 4 and 8.5 radians. All right, so we're going to do a little bit of common sense work over on this one, okay? 3 pi over 4. We know that 2 pi radians is the same thing as 360 degrees. So that should tell us that pi radians is 180 degrees. Now, if you're given radians in terms of pi, what you can do to convert to degrees is simply take that pi and substitute in 180 degrees. Okay? So 3 times 180 over 4 is going to give us 135 degrees. So again, if it's written in terms of pi, what you can do is you can plug 180 degrees in for pi. Now, if it's not written in terms of pi, you do have to go and do that proportion. Degrees over radians equals 180 over pi. Cross multiply. And divide by pi. And what you're going to use for pi is your pi key. Okay. So 180 times 8.5 divided by pi. And if you want, we can show you how to do that. I'm going to use my fraction template. 180 times 8.5 divided by, here's my pi, and I get 487.01 approximately degrees. That's an approximation, I did round. Okay. All right. Find a positive angle and a negative angle that are coterminal with 2 pi over 3. Many answers are possible. We talked about coterminal angles in the last lesson. We know coterminal angles are simply multiples of 360 degrees. And again, since we're talking in terms of radians, we're not saying 360, but we are saying 2 pi. Okay, so this is actually pretty simple. We're going to take 2 pi over 3. And we can add 360 degrees, or 2 pi radians, to get a coterminal angle. So 2 pi over 3 plus 2 pi. Now we know in order to do this, we need a common denominator, which, since this is 3 and this is 1, it's going to be 3. So if I multiply this by 3, I have to multiply this by 3. 6 pi over 3. When I add these, 2 pi over 3 plus 6 pi over 3, I get 8 pi over 3. So that's a coterminal angle. We can also subtract 2 pi over 3 minus 2 pi. Same idea, except we're doing subtraction, which is going to give us negative 4 pi over 3. Okay? All right, find the complement and the supplement of pi over 6. All right, so if we remember from last time, complement is our 90, and supplement is our 180. All right, so if I want 90, remember, 360 is 2 pi. I'm a little crazy here. Oops. $180 is going to be pi. 90 is going to be half a pi. Okay? So we're going to need these here. So complement means it has to add up to be 90 degrees. So what I'm going to do is I'm going to take my 90 degrees, or my pi over 2 radians, and I'm going to subtract from it my pi over 6, which we know to be 30 degrees, or pi over 6 radians. We do need a common denominator. Which is going to be 6. So if it's going to be 6, I'm going to have to multiply this by 3 over 3. So 3 pi over 6 minus pi over 6, which is going to give us 2 pi over 6, or pi over 3. Oops. Sorry about that, guys. Okay, so now if we're talking about the supplement, that's 180 degrees, or pi radians. We're going to do pi minus pi over 6, just like we did with the complement. Common denominator, we know it's going to be 6. This one's simple, 6 pi over 6, because if those were to cancel, I get back my pi. And we get, nice and easy here, 5 pi over 6 radians. Okay, so we're going to stop here for today, and we'll finish up the rest of this video in the next the rest of this lesson in the next video. So make sure you come prepared with any questions that you might have, and I will see you guys tomorrow. Thanks.